Now let's take a look at the same two-step equation when there are variable terms on both sides and only one constant term. So we have the same equation, negative 14a equals negative 25 minus 19a. Now remember, when we're trying to solve the two-step equation with variable terms on both sides and one constant term, we want to start by getting all of the variable terms on one side and all of the constant terms on the opposite side. So in this case, we want to move the negative 14a and negative 19a to the same side. So we're going to take that negative 14a and we're going to take that negative 19a because they are like terms. This time, we're going to try moving the negative 14a over to the right side. And let's see what happens here. Now remember, the equal sign in this equation means that we have to move terms by doing the inverse operation to the term and doing the opposite to both sides of our equation, both sides of our equal sign. So in this case, we're going to add 14a to both sides of our equation. On the left side, that cancels out to be 0. Negative 14a plus 14a gives us 0. And on the right side, we're still left with those two terms. We have negative 25 and then our negative 19a plus 14a, which is going to give us negative 5a. So now, when we rewrite this new equation, we have to remember to keep the equal sign there. So on the left side, all we have left is 0. There are no other terms left. So we just write 0 on the left side. We bring down our equal sign. And on the right side, we just perform our same operation that we have written down. We have our negative 25 minus 5 times a. And our new equation just has a 0 on the left side, but it is 0 equals negative 25 minus 5a. And this is our new two-step equation. So from here, we can use our same steps. We still use SADMAP, reverse order of operations. We add 25 to both sides of our equation. Just on the left side, we're adding 0 and 25. So on the right side, we still cancel out that negative 25 plus 25. That's still 0, and we're left with negative 5a. But on the left side, we're left with 25. And our new equation is now 25 equals negative 5 times a, which is our one-step equation. And we can divide both sides by negative 5 to give us that 1, when the negative 5 divided by negative 5 on the right cancels out. And we can bring down our answer, negative 5 equals a, the same thing as a equals negative 5. And that's our answer. For our check, all we do is bring that negative 5 and plug it in to where there were the two a's in our original equation. It looks exactly the same as before. We go ahead and solve that to get our 70 equals 70, which is correct, which means our a equals negative 5 was the correct answer. And it's the same answer that we had in the last video when we moved negative 19a over to the left side. So now there are multiple ways always to solve equations. It's just some ways take less steps and some ways take more steps. So we want to work on being efficient and finding the best way to solve our equation. So in this case, moving that negative 19a over to the left side would be faster. But we can still solve our equation by moving the negative 14a over to the right side. And this is how we can solve two-step equations when there are variable terms on both sides and one constant.